Hi guys, in this video I'm going to show you some challenging mole calculation, and this time it's about actual yield, theoretical yield, and percentage yield. So for these yield, let's take a look what do they mean. So theoretical yield is the mass of product expected if the reaction proceeds exactly as shown in the chemical reaction, and actual yield is the mass of product actually produced from the reaction. And sometimes if you are asked to find percentage yield, is actually equal to the actual yield over theoretical yield times 100%. So what does it mean for the actual yield or the percentage yield is that in general you get a value or percentage yield less than or equal to 100%. You will never get a percentage yield more than 100% unless you use the wrong data. So let's take a look here. It also implies that actual yield can sometimes less than the theoretical yield, and this may be due to some experimental error. And like for filtration, you may somehow transfer the products or separate the products, but there may be some products that is left in the filter paper, you cannot retransfer it, and hence you get a loss of product from your reaction. And there's also some other reason, but it's due to different contexts. So let's take a look for the example here. Ethine react with bromine to form tetrabromoethane, and in the experiment for 2 grams of ethine react with 5.2 grams of bromine and forming 5.02 grams of tetrabromoethane. So based on this, highlight the keywords and you'll notice that 2 grams ethine, 5.2 grams bromine, and 5.02 grams of tetrabromoethane. So for tetrabromoethane, this 5.02 gram is actually the actual yield. And by comparing the number of mole of ethine and bromine, you can determine the limiting reactant. And based on the number of mole of limiting reactant, you can also find the number of mole of the product and hence find the mass of product, and this will be the actual yield. So let's take a look for this number. Calculate the number of mole of ethine by mass over molar mass. Calculate the number of mole of bromine by mass over molar mass. And after that, from the chemical equation, you know that 1 mole of ethine reacts with 2 mole of bromine. So 0.0769 mole of ethine should react with 0.0769 mole times 2 for the bromine number of mole, and which is equal to 0.1538 mole of bromine. And therefore, when you compare 0.1538, this is theoretically we need that sort of amount to react with the ethine, but we only got 0.0325 mole of bromine. So when you compare these two data, you'll find that, oh, bromine is limiting. There's not enough bromine to react that much amount of ethine, and hence bromine is the limiting reactant. And then you can find the number of mole of the tetrabromoethane by using the number of mole of bromine, and you can find the value and hence find the mass of the tetrabromoethane. And I would like to take a look here is that I actually run off the value with three significant figures. Okay, 5.62. So this actually applies the skills you learned in both Series 7s about limiting reactant and also the basic chemical stoichiometry. So with the theoretical yield, actual yield, and you can apply to the percentage yield equation, and you'll find it is 89.4%. Okay, so this is rather similar, and there's a practice that I would like you to try, and you can work on a piece of paper and see if you can calculate the final answer. If you have any question, you cannot do it, I would suggest you rewind, step back for the previous video parts, okay, drag your timeline and find it. And if you have any further questions, feel free to leave me a message in YouTube or whatever. So see you guys.